Hello friends, this is Nidhi Gupta. Today we will study the topic carbon and its compounds. So, what is carbon and where it is found? What is carbon? You have earlier studied about carbon. A carbon is a non-metal. Okay, first of all, carbon is an element and carbon is a non-metal. So what is the atomic number of carbon? Atomic number of carbon is 6. Atomic number of carbon is 6. And how many electrons are present in carbon? It will also be 6. And number of neutrons and number of protons are 6 in number in carbon. So here you can see the atomic structure of carbon. In its innermost shell there are 2 electrons, and in its outermost shell there are 1, 2, 3 and 4. In its outermost shell there are 4 electrons, or we can say that there are 4 valence electrons in the outermost shell of a carbon atom. So, being present in less amount in nature, carbon is the most important and the main element of all life forms. We can also say that carbon is the basis of all life forms. Many of the medicines, pencils and lot of things are made up of carbon and its compound. Even the clothes you wear are also made up of carbon. Carbon, though present in very less amount, it is the main element. Okay, and the carbon is present in earth crust in 0.02% in the form of minerals like coal, petroleum, hydrogen carbonates, carbides, etc. And in atmosphere, carbon is present in the form of carbon dioxide in 0.03%. So, what are ionic and carbon compounds? Ionic compounds. You have earlier studied about the ionic bonding. Okay, the bonding which is found in ionic compound. The bonding is called ionic bonding. What are ionic compounds and what are their properties? These compounds have high melting point and boiling point and conduct electricity in solution or in the molten state. Hence, they are good conductors of electricity. And why they are good conductor of electricity? Because they produce ions in molten state, which are the carriers of electricity. While carbon compounds have low melting point and boiling point and don't conduct or conduct very less amount of electricity in solution. Hence, are poor conductor of electricity and don't produce any ions in molten state. What about the force of attraction in ionic compound? Force of attraction in between these ionic molecules is strong, and this bonding in these molecules are formed by the removal and gaining of electrons simultaneously between the different atoms. While in carbon compounds, the force of attraction between their molecule is weak, but the intramolecular force is strong. That is, that is the force that is the force within the molecule is strong. Hence, their melting point and boiling point is very low. Bonding in such compound are formed by the sharing of electron, and that bonding is called covalent bonding. Examples of carbon compounds are acetic acid and methane. Okay, and examples of ionic compound are NaCl and KCl. Here you can see the ionic compound. Example, sodium chloride, ionic compound, sodium chloride. Sodium, as we all know that the sodium is a metal, and what is the atomic number of sodium? Sodium's atomic number is 11. Okay, then its electronic configuration will be 2, 8 and 1. Okay, and 1 is the electronic configuration of sodium. Okay, and 1 is the valence electron. So sodium has one valence electron, while the chlorine atom has atomic number 17 and its electronic configuration 2, 8, 7, and 7 are the valence electrons of chlorine. So what is happening here? Sodium, being a metal in nature, have the tendency to lose the electron. Here it is losing its electron. And chlorine, a non-metal in nature, have the tendency to accept an electron, and here it is accepting an electron from the sodium. And in this way, two ions are formed, that is sodium cation and the chloride ion, anion. And in this way, the bonding formed between these ions of opposite charges is called the ionic bonding. So here is the example of sodium chloride, which is a ionic compound, and here we will here we can see methane. As you all know that the carbon has 4 valence electron in its outermost shell. Here the electron of carbon is represented by the blue dot, and red dot are the electrons, are the valence electrons of the hydrogen atom. Here the sharing of 4 electron pair is occurring between one carbon atom and the 4 hydrogen atom. One carbon atom and 4 hydrogen atom. 4 hydrogen atoms. So one carbon atom, one valence electron of a carbon atom is shared with the another one electron of number 1, we can say number 1 hydrogen atom, and in this way one pair of electron is shared between a carbon atom and number 1 hydrogen atom. Similarly, second valence electron of a carbon atom is shared with the second hydrogen atom valence electron, and another pair of electron pair is shared between the carbon atom and the second one hydrogen atom. Likewise, similarly, the third valence electron of a carbon is shared with the third hydrogen atom valence electron, and in this way third electron pair is shared between a carbon atom and the third hydrogen atom. Lastly, the fourth valence electron of carbon is shared with the fourth hydrogen atom valence electron, and in this way all four pairs of electrons are shared between one carbon atom and four hydrogen atom, and the bond formed in this way is called the covalent bond. So many of the elements have the tendency to complete their octet in order to attain a noble gas configuration, and therefore carbon also has the tendency to attain a noble gas configuration. But how it attained the noble gas configuration? A common question arises in mind that why carbon atoms can't gain 4 electrons? Here is the atomic structure of carbon, and here are the 4 electrons which are trying to enter in the outermost shell of the carbon. See, they were trying to enter in the outermost shell of the carbon, but they get failed in their attempt. So why they get failed in their attempt? Why carbon atom is not accepting the 4 electrons in order to complete their octet by gaining 8 electrons in their outermost shell? The reason behind that is the carbon nucleus don't have much power to hold the 10 electrons. So the carbon atoms can't gain 4 electrons, as it is difficult for carbon nucleus to hold the 10 electrons. So that's why carbon atom can't gain 4 electrons. So why carbon atom can't lose 4 electrons? Although carbon atom can't accept 4 electrons, that means they can't accept 4 electrons, then in order to attain noble gas configuration, they will try to lose 4 electrons. But in the case of carbon, losing of 4 electron is also not possible. Why? You can see here is the strong force of attraction between the carbon nucleus and the outermost electron in the outermost shell. Here the electrons are trying to escape from their outermost shells. Here all these 4 electrons are trying to escape from the outermost shell, but they were failed to do this. Why they were failed to do this? Because these removal of 4 electrons need a large amount of energy, required a large amount of energy for carbon, and it is not possible for the carbon to manage such a high amount of energy. That's why the 4 electrons in their valence shell are not able to escape from their outermost shell. In this way, carbon can't lose 4 electrons in order to attain a noble gas configuration. So, what will they do now? As we have seen that neither carbon can't lose 4 electrons nor carbon can gain 4 electrons. So, in order to fulfill its octaves, it shares electrons with different or same atoms in order to complete their octave. Like carbon, other elements such as oxygen, hydrogen, nitrogen, etc. complete their octet in order to achieve noble gas configuration by sharing electrons with other atoms. Here you can see the example of hydrogen. How hydrogen atoms, you can see how hydrogen atoms are sharing their electrons in order to form an H2 molecule. Here the atomic number of hydrogen is 1, and these two hydrogen atoms are sharing a 1 electron pair. These two hydrogen atoms are sharing 1 electron. These two hydrogen atoms are sharing 1 electron pairs in order to complete their octet. So here they are forming a covalent bond, a single covalent bond. In this way, they are attaining the electronic configuration of the next noble gas configuration, noble gas, that is of helium. Similarly, in oxygen also share electron pair with another oxygen atom in order to form a oxygen molecule. So here you can see that the number of carbons present, number of electron present in oxygen are 6, and the number of valence electrons in oxygen the atomic number of oxygen is 8, and the number of electron present in oxygen is also 8. Number of electron present in oxygen is also 8, and the number of electron present in their valence shell is 6. So these 6 electrons are participating in the covalent bond formation. How? You can see here, this oxygen molecule has electrons which are represented in the as red dots, and this one oxygen atoms has 6 electron which are represented as cross. So here two pairs of electrons are shared between the two oxygen atoms. In this way, a double bond is formed between the two oxygen molecules. Here, a double bond is formed between two oxygen molecules. In this way, both oxygen atom attain their noble gas configuration. Also, you can see in nitrogen, the atomic structure of nitrogen atom. Atomic number of nitrogen is 7. And what will be its electronic configuration? It will be 2, 5. So number of valence electrons are 5, and these 5 valence electrons are now going to participate in the covalent bond formation with the another element. So you can see how these two nitrogen atoms are sharing electron pairs between them and thus forming a compound that is N2 molecule. So here you can see that this nitrogen has this nitrogen has electrons represented as the orange dot, and this nitrogen has electrons represented as green dots. So here you can see that these 3 electrons from each nitrogen were shared, and in this way 3 pairs of electrons are shared between the 2 nitrogen atoms, and the 3 pairs of electrons are shared. That means 3 bonds are formed between the 2 nitrogen atoms, and this bond is called the triple bond. This bond is called the triple bond. So what about CH4 or methane? Which bond is present? Already we have discussed about this compound, that the bond present in the methane is covalent compound. And what kind of covalent bond is present between the carbon and the hydrogen atoms? It is single bond. So many scientists have discovered till date that there are about 3 million carbon compounds whose chemical formulas are known. These carbon compounds are very big in number as compared to other elements compound, and the reason behind that is the covalent bond which is found in their compounds. The 2 factors which contribute to the large number of carbon compounds are: number 1, tetravalency, and number 2 is catenation. Both these properties led to the large number of carbon compounds. Carbon has the valency 4. That means it has carbon has the valency 4 and it has 4 valence electrons. So what do you mean by the valency? You have earlier studied in your previous class that the valency is the power of an atom to combine with another atom in a compound. So here the valency of carbon is 4. That means it has the power to combine with 4 carbon atom or with the atoms of some other monovalent atoms. And monovalent atoms means that their valency is 1. Like monovalent atoms like sodium, lithium, chlorine, and the bond that carbon forms with these elements is strong. Okay, the bond that carbon forms with these elements is strong. And why the compound formed by the carbon atom is strong as compared to other element compounds? Because the carbon atom size is very small, in such a way that the size of carbon atom is very small, and this helps the carbon nucleus to hold the shared pair of electrons which they share with the other atoms while forming a compound. In this way, the compounds of carbon are very strong and stable. That's why the large number of carbon compounds exist in nature. Catenation. Catenation is the property by which carbon atom form bonds with the other carbon atom in order to form a large skeleton of carbon. In this way, they give rise to a large number of compounds. This property is called catenation, which is found in C means carbon, which is found in carbon compounds to the maximum extent, unlike other elements. Also, carbon-carbon bonding is very stable as compared to other elements bond. Catenation is the property which is found in various elements, but in the carbon element it is found in the carbon compounds to a maximum extent. Catenation is found in silicon also, but the catenation is not very much to produce a large number of silicon compounds, and also these silicon compounds are not very stable as compared to the carbon compounds, because in carbon compounds the carbon-carbon bonding is very stable. Also, a carbon skeleton can be in the form of long chain of carbon like this, or it can be in the form of branch chain of carbon like this. Or it can be in the form of carbon skeleton can be in the form of ring like this. Also, carbon bond with other carbon. Also, there are various bonding present between the carbon-carbon atoms. These are single bond. You can see here, this is single bonding. Okay. Also, there are double bonding between the carbon atoms, or there are triple bonding between the carbon atom. So, for the compound which have single bond between the carbon atoms, those compounds are called saturated compounds. And the compounds which have double bond and triple bond between their carbon atoms, they are called unsaturated compounds. So I hope now you are understood about the now you are understood why the carbon has a large number of compounds unlike other elements compound. So do tell me in the comment section that what type of bonding is present in CO2. What type of bonding is present in CO2 or in carbon dioxide? Okay. Do tell me in the comment box that what type of bonding is present in CO2. If it is A, write A. If it is B, write B. If it is C, write C. And if it is D, write D. So, if you like my video, then give a like and also tell me how you like my topic. Do comment in the comment box, and please, if you are new to my video, if you are new viewer, then do subscribe my video. Okay, take care. Bye bye.